Alright, this is our final video on algebra and geometry. It's been a good run. So today I wanted to talk about composite functions and inverse functions. So a composite function is really simple. It's basically taking another function. So let's say there's some f of x. I won't define it to be anything. And there's some random g of x, some arbitrary one. And now we have z of x. Suppose that z of x is composed of taking on the values of g of x. So it'll look something like this. So whatever you put in as a value for x, it'll plug into g of x, and then whatever value you get for that, it's going to be f of whatever g of x is. Alright? So it's going to be, let's say we define g of x at g of 1 to be 2. So if you plug in 1 in z of x, and you go to g of x, plug in 1, you get 2, then it's going to end up being f of 2. And then whatever f of 2 is, that's going to be the answer to whatever z of 1 is. There's also a notation that you should know about composite functions. It will be based on this thing right here. It's a circle, I don't know what it's called. Well, that's what it looks like. Just this little circle in between the functions. And then it'll be of x. So it's like connecting it, but this one would go into the interior of f of x. Alright, so I'm going to define g of x now. I'm going to say that g of x equals x plus 1. And over here, it equals x squared. Now suppose that we do the same format here. How do we do it? Well, the thing is that whatever you see in g of x, you just plug in that function over here. And whatever happens to x, you do to the x right there. So you have x plus 1. So you would actually plug it into x squared, so it'll be x plus 1 squared. Or you could find the answer regarding g of x. So let's do z of 4. So z of 4 involves you plugging into g of x first. So g of 4 is going to be 5. And then f of 5 is going to be 25. But if we do this, where we just put in x plus 1 into the x squared, so it'll be x plus 1 squared, we get the same answer. So x equals 4, and then 4 plus 1, 5, 5 squared, same answer. And that's how you do composite functions. Even if it were like a logarithmic function, you could do the same thing. Alright, now let's move to inverse functions. This is going to be quite an easy lesson. I didn't consider this too hard. I mean, it's not up to me to judge whether or not something is hard. So just tell me if I need to go in depth. Alright. Suppose that we have some f of x. And that is going to be defined to be y. So y equals f of x. Now, an inverse function can be defined to be taking the inputs and making it outputs, and making the outputs become inputs. And the thing about an inverse function is that it's a reflection over, alright? And it'll be a reflection over y equals x. So whatever function you have, it's going to reflect over like this. Like f of x over here, and then reflects over here. So y equals f of x, you just have to do f of y equals x. But how do you transform it into that? Because you can put it back into that format where it's y equals f of x, but it requires you to do simple rules. Let's say that you want to find the inverse of x squared. So right there is going to be y equals x squared. Plug in the y into where the x would be. So you have your y equals x squared. Now it's going to be x equals y squared. All you have to do is just manipulate it to where it becomes a function of y again. So it'll be the square root of x. And you already know it's going to become a reflection over because y equals x squared is shaped something like this. Oh, well, not something like that. And this will be the y equals x. And the graph, dang it, this is a dumb line. And the graph looks something like this. You can already see that it reflected over just like that. That's how inverse functions work. So it only works with this thing called a one-to-one function. A one-to-one function is it's like a continuous thing. I forgot how to describe it. But basically, it just can't like break anywhere so that you can actually reflect it over. I'm trying to think of something else. Yep, I think we're done. Follow-up video coming up soon. God bless you. See you in the next video.